Welcome to Astronomy Daily. I'm your host, Anna. Today, we've got a packed episode covering India's ambitious new space projects, SpaceX's plans to catch Starship, exciting discoveries about water on the moon, groundbreaking observations from a new X-ray telescope, and concerns about satellite interference with radio astronomy. Let's dive right in. First up today. India has recently greenlit an ambitious slate of space projects, showcasing its commitment to becoming a major player in space exploration. The Indian government has allocated a substantial $2.7 billion for these endeavors, which are set to push the boundaries of the nation's space capabilities. At the forefront of these plans is the Chandrayaan IV mission, a bold lunar sample return effort aimed at collecting material from the moon's south polar region. This mission builds on the success of Chandrayaan III and demonstrates India's growing expertise in lunar exploration. Equally exciting is India's approval of its first Venus orbiter mission, known as Shukrayan. While initially planned for an earlier launch, the mission is now targeted for 2028. This venture will allow India to join the select group of nations that have sent spacecraft to our planetary neighbor. Perhaps most ambitious is India's plan to develop its first space station module. Named the Bharatiya Antariksh Station, or BAS, this project signifies India's aspirations for a long-term human presence in space. The first module is slated for launch by the end of 2028, with full operational status expected by 2035. These projects not only highlight India's technological advancements, but also underscore its determination to become a key player in the global space arena. Let's delve deeper into India's ambitious Chandrayaan IV mission. This lunar sample return endeavor is set to be a complex operation, involving 4 modules launched across 2 separate rocket flights. The first launch will carry a lander and a sample-collecting ascender vehicle, targeting the lunar South Pole region. The second launch will deliver a transfer module and a re-entry module to lunar orbit. The mission's primary goal is to collect lunar samples from Shiv Shakti Point, where the Chandrayaan III spacecraft previously landed. Once collected, the ascender will launch from the moon's surface and transfer its precious cargo to the re-entry module. This module will then make the crucial journey back to Earth, aiming for a safe touchdown with the lunar samples intact. This ambitious project not only pushes India's space capabilities, but also sets the stage for future crewed missions to the moon. The technologies developed and tested during Chandrayaan IV will be critical for India's goal of landing astronauts on the lunar surface by 2040. And India's space ambitions continue to grow, with plans now approved for the country's first space station module. The module, named BAS-1, is set to launch by December 2028. This marks a significant step for India's space program, as they aim to have a fully operational space station by 2035. Meanwhile, India's Venus orbiter mission, known as Shukrayan, has faced some delays. Originally planned for an earlier launch, the mission is now targeted for March 2028. The orbiter will carry a suite of scientific instruments to study Venus's atmosphere, geology, and evolution. These projects, along with the Chandrayaan IV mission we just discussed, demonstrate India's commitment to becoming a major player in space exploration. With a budget of nearly $150 million allocated for the Venus mission alone, it's clear that India is investing heavily in its space future. Next up, SpaceX is gearing up for another groundbreaking achievement in spaceflight history with their upcoming Starship test flight. The company plans to attempt something truly revolutionary, catching the massive, super heavy first stage booster using the chopstick arms of the launch tower at their Starbase facility in Texas. This ambitious maneuver, if successful, would take rocket reusability to the next level. Instead of landing on a ship at sea or a designated pad, catching the booster right on the launch mount could dramatically reduce turnaround time between flights. SpaceX has been practicing with these tower arms, designed to lift both stages of Starship. Recent photos show them raising the super heavy booster to the expected catch height. While SpaceX says they've been ready for this next test flight since early August, regulatory reviews have delayed the launch. The FAA isn't expected to complete its assessment until late November at the earliest. When it does fly, this will be Starship's 5th test flight. Each previous mission has shown improvement, with the last one reaching orbital velocity before a successful splashdown of both stages. If SpaceX can pull off this catch, it would be a major milestone in their quest to make Starship rapidly and fully reusable, a key to their goals of affordable space access and eventual Mars colonization. And let's take a look now at what's going on in China. Chinese private space companies are making significant strides in developing reusable rocket technology. Two firms, Deep Blue Aerospace and Landspace have recently conducted impressive high-altitude hop tests with their prototype vehicles. Landspace achieved a notable milestone in late August with its Shukrayan 3 hopper prototype. The vehicle soared to an altitude of 10 kilometers during a 200-second flight that included a crucial engine reignition test. The single Tianke 12B engine performed flawlessly, accurately landing just 1.2 meters from the center of the pad. Not to be outdone, Deep Blue Aerospace is preparing for its own high-altitude test. Their Chandrayaan 1 first-stage prototype, also known as Nebula 1, is being readied for a flight between 5 and 10 kilometers. This follows successful lower-altitude tests with their subscale Nebula M vehicle. Both companies are aiming to develop fully reusable orbital launchers. Landspace's finished Shukrayan 3 will stand taller than a Falcon 9 at nearly 77 meters, powered by 9 methane-fueled engines. Deep Blue's Chandrayaan 1 will feature 9 kerosene-burning engines in a configuration similar to the Falcon 9. These tests represent significant progress for China's commercial space sector as they work towards cost-effective, reusable launch capabilities to serve the growing demand for satellite deployment. New research has revealed that water is far more abundant on the moon than previously thought. A study based on data from NASA's Moon Mineralogy Mapper has shown that water and hydroxyl molecules are widespread across the lunar surface, not just confined to the poles as once believed. The analysis found water hidden in ice deposits in shaded areas and inside enriched rocks. Interestingly, hydroxyl molecules, which are components of water, form when solar protons interact with oxygen in the lunar regolith. These findings suggest that future astronauts may be able to find water resources even near the moon's equator. 2 types of lunar rocks were identified as potential water sources. The dark mare basalts are relatively dry, while the anorthosite rocks found in the lunar highlands contain more water. Heating these rocks could potentially provide a long-lasting water supply for lunar missions. While polar ice deposits remain the most accessible water source, this new understanding of lunar water distribution opens up possibilities for more flexible mission planning. However, extracting water from rocks would require significant energy expenditure. These discoveries are crucial for future lunar exploration and potential bases, as they could reduce the need to transport water from Earth. Understanding the moon's water resources is a key step in making long-term lunar missions sustainable. Japan's X-ray Imaging and Spectroscopy Mission, or XRISM, has unveiled its first results, and they're absolutely fascinating. This space telescope, operated by JAXA with ESA's participation, has captured stunning observations of 2 cosmic phenomena. First up, XRISM studied a supermassive black hole at the heart of galaxy NGC 4151, about 62 million light-years away. The telescope tracked superheated plasma circling the black hole at distances as close as 0.001 light-years. This unprecedented view is giving astronomers new insights into how these cosmic giants feed and grow. But that's not all. XRISM also turned its gaze to a supernova remnant called N132D in our galactic neighbor, the Large Magellanic Cloud. This cosmic bubble of plasma, ejected from a massive star about 3,000 years ago, revealed some surprises. Instead of the expected spherical shell, the remnant is more donut-shaped and expanding at a mind-boggling 2.6 million miles per hour. Even more astonishing, its temperature clocks in at a scorching 18 billion degrees Fahrenheit. These observations are helping scientists better understand the life cycles of massive stars and how elements are distributed throughout the cosmos. With over 3,000 proposals submitted for future studies, it's clear that XRISM is just getting started in revolutionizing our view of the X-ray universe. While Starlink satellites have already raised concerns about their impact on visible light astronomy, new research reveals they may pose an even greater threat to radio astronomy. Recent observations using the low-frequency array, or LOFAR, have shown that SpaceX's second-generation V2 mini Starlink satellites are emitting up to 32 times more radio waves than their predecessors. These unintentional radio emissions are astonishingly bright, about 10 million times brighter than the faintest astronomical objects LOFAR can detect. This means any radio telescope observing when a Starlink satellite passes overhead could have its data completely overwhelmed. As companies like SpaceX and OneWeb plan to launch tens of thousands more satellites, astronomers are increasingly concerned about the future of radio astronomy. Without proper regulations and cooperation from satellite operators, our ability to study the universe through radio waves could be severely compromised. This underscores the urgent need for dialogue between the astronomy community and satellite companies to find solutions that allow both internet access and scientific research to coexist. And that brings us to the end of today's Astronomy Daily. I hope you've enjoyed this cosmic journey through the latest space and astronomy news. Thanks so much for tuning in. If you're hungry for more, head over to our website at astronomydaily.io. There you can sign up for our free daily newsletter, catch up on all the latest stories with our constantly updating newsfeed, and listen to all our past episodes. Don't forget to follow us on social media too. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. This is Anna, signing off until next time. Keep looking up.
Astronomy Daily. Stories we told. Stories we told. Stories we told.